So before I jump into the presentation, let's try and define what privacy means. Now, unlike security, and a lot of you who work in tech companies or even who do not work in tech companies have an intuitive sense as to what security means, a credit card breach, identity theft. So there's a very intuitive definition. Privacy is harder to define. So in order to define it, let's go back to several decades ago with Justice Potter Stewart. He was once asked to define what hardcore pornography meant, and he said he didn't have a definition for it, but I'll know it when I see it, was his response. So how does that help us define privacy? So in order for that, let's come back a little bit in the future and talk about me and my spouse and our first trip to meet my family after we got married. So after we got married, I thought it'd be a nice idea for her to actually meet my family. So we flew to Mumbai, and against my advice, my wife, who had never gone anywhere to the east of London, decided to eat some street food on the streets of Mumbai, and she enjoyed it, and just as I forecast, promptly fell sick. And we went to see the doctor, and it was all okay, just a case of an upset tummy. The doctor said, take these medicines for a couple of days and you'll be fine. Okay, so far no harm, no foul. And then at the end of the appointment, right before we were done, he decides to yell out loudly the details about the prescription to his assistant who's sitting across the room. The door's open, and he yells out the names of the medicines, then my wife's name, then her weight, her statistics, and a bunch of other details. So the guy writing the prescription got all the information, but so did all the patients sitting outside. And just in like 3 seconds, somebody who meant us no harm destroyed my wife's privacy. So Justice Stewart said that when it comes to porn, I'll know it when I see it. With privacy, you'll know it when you lose it. So remember that when you make decisions about other people and their data, and that's a sensibility I try to bring to my job and my teams and my executive leadership team when I advocate for a privacy program. So here's the agenda for the talk with that background. First, I'll introduce myself a little bit, talk about privacy in the context of the tech industry and the economy as a whole, then introduce two parts of the conversation. The first is, how do you build a privacy architecture when you collect data from your users and your customers? Then I'll talk about building privacy architectures for data sharing. That is what happens when data leaves your company. So you need an architecture for the collection, the intake of data, and an architecture for the exiting of data from your company. Then we'll look at lessons and a summary, and then I'll take your questions if we have time at the end. So a little bit about me. I have been in privacy for about 10 years now. I got into it when nobody else wanted to work in it. I took the job literally because nobody else wanted it, and it was an easy way to work with some smart people in the company, some smart attorneys who I liked working with. So that was at WebMD back in the day. I then started the privacy engineering program at Nike and then at Netflix a few years ago. I ran the trust organization for Google Cloud, GCP. And currently, for the last few months, I've been leading the privacy architecture organization at Uber right across the street here. So that's a little bit about me. So as I said before, when I first got into privacy, it was a very esoteric, abstract concept. And now it's the subject of memes and cartoons. And when newspaper cartoons make fun of your discipline, you know you've arrived. So I feel somewhat happy about it. But there is a serious side to privacy. And I do not want to be in the position of the kid. I do not want to be in the position of the president. I do not want to be in a situation where I'm surprised or I've surprised somebody else. There is a lot of power in data and privacy, and for far too long, we as an industry have not done very well. So a lot of what we're doing here today is about rectifying some of those mistakes, but also setting us up for success so we can grow more responsibly. So for far too long, there has been this unwritten contract between us and our customers. You know, we're going to build amazing products. Our users will use those products, and they'll give us a ton of data. We will then use that data to build better products. They will then use them. We will get more data, et cetera, et cetera. So the virtuous circle will keep on spinning. And at some point, that contract didn't quite work out very well. So there are 4 key facts when it comes to privacy that we're now reckoning here. A, we as businesses, and I'm assuming most of us or all of us in this room work for companies that collect data. So we collect a ton of data. But there is no conceptual certain way of how do you measure risk? Like, how do you decide how sensitive this data is? There is no one right way to do it, but most companies don't even know where to start. And as a result, we don't always know how to protect data preemptively. We always react when there's a breach or a consent decree. So it's a very reactive science. So privacy suffers because of that, as does security for that matter. And because we don't do it right when data comes into our company, we don't do it right when data leaves our company. So that risk just keeps on growing. It's like a headache that you do not treat. It keeps getting worse and worse and worse. And the customers are catching on. Like if we believe that our customers don't care about privacy, there was a PwC survey that I looked at when I was preparing for a course I taught on LinkedIn to start a privacy program. And there are 4 key numbers that caught my attention. First, 69% of respondents believe that companies are vulnerable to hacks. And frankly, considering the headlines we see these days, I'm wondering what the remaining 31% are thinking. So the number ought to be much, much higher. 90% of respondents believe that they lack complete control over their information, which goes back to trust and transparency. Just 25% of respondents believe that most corporations handle sensitive data well. And only 15%, and this is especially ominous, only 15% believe that we will use their data in a way that benefits them. So, as I mentioned before, there is this unwritten contract, and that contract, in order to work, has to benefit both sides equitably. And at some point, that balance has been horribly lopsided. So these numbers speak to that. But there is a silver lining to this, and let me talk about two more numbers in that study. First is 72% of the respondents also believe that businesses rather than the government are better equipped to protect their data, which you might wonder why, considering all the numbers we just saw. And there's two insights to this. The first is, when it comes to the speed of coming up with privacy infrastructures, businesses are always going to move faster. It takes a longer time for government because of the inherent nature of government to make things happen. So that's number one. But the second thing is, we don't have a choice when it comes to dealing with government. You can stop using certain apps, but you cannot stop dealing with the government. When I became a US citizen, that naturalization process took about 11 months. I had to submit so many documents. The government wanted documentation about my maternal mother-in-law, who I never met, who died 21 years before I even was born. And they wanted to know her birth certificate. And at the time when she was born, they didn't even issue birth certificates where she was born. I had no say in why that information was germane to me becoming a citizen or how it would be protected. So there is an imbalance there as well. So there is a reason why people want to trust us. We just need to give them a reason to. That's a lot of what this talk is going to be about. But the second number is my real favorite one, the 88% number. 88% of respondents said that they will willingly give us their data if they trust us and if they know how their data will be used and why it's being used. So again, it goes back to trust and transparency. So there is an opportunity here even in the lack of trust. So what do we learn from all of this? Three things. First, privacy is an all hands on deck. Do not just let the legal team of the company think that it's for them to defend. You're there to help. Engineers, data scientists, the IT team, the security team, they all need to have a seat at the table. The second thing is security and privacy are not the same thing. They are related, but when you have good security, privacy can begin. One depends upon the other, but they're not the same thing. And then, as I said before, think beyond breaches. Don't just wait for your privacy program to emerge when there's a breach. Think about privacy when it comes to collecting information from your users, because that's the first point at which the user comes into contact with your company, and it goes back to trust one more time. And also, how do you think about privacy when data leaves your company? So as we go through this talk, come back to these 3 points in your mind. So this brings me back to the first part of this talk, which is how do you build a privacy architecture for data collection? So people often talk about privacy by design, but really privacy by design infers a lot of different things for different people. I like to think of privacy by data and design. That is, you have to think about data and the people behind the data as a first-class citizen. It's not a set of numbers, it's a human being who is trusting you with his or her or their data. So when it comes to data classification or doing data architecture properly for collection, in my mind, there are 4 key steps. The first is the data classification. That is part of the planning phase. The second is setting up the governance standards to protect that data. That is, again, part of the planning stage. The third, which I'll be talking about in great detail, is inventory of the data. And the fourth is actually executing the data privacy. So we'll be looking at these in different levels of detail. But first, how do you classify your data? So as I mentioned before, data is the fuel that runs our innovation engine. And if data were mishandled, there's different levels of risk depending upon what gets mishandled. So the data classification is the way to express your understanding of the risk when it comes to the data you are collecting. So this is a way for you to partner with your legal teams. I'm thinking about legal, privacy, security, data science, marketing, legal, business development. Everybody who has a say in how you as a company interact with your user needs to be at the table. And let me give you an example of what that would look like in a second here. But data classification answers 2 fundamental questions. The first is, what is this data? And second, how sensitive is it? That is, what would happen if that data were to be mishandled? So here's an example, as I mentioned before. So this is a very, very simplistic example of how I would do data classification. So since I'm coming from Uber, this was something we kind of worked on at a very early stage. So I'll just focus on tier 1 here. What would be extremely sensitive if you are, say, an Uber driver? Who you are, where you are. Now, I'm an alumnus of Netflix, and what you watched 4 days ago might be embarrassing if somebody found out. but who you are and where you are goes to your physical safety. So that is data we treat very, very, very seriously, and that is appropriately labeled as tier 1 in our classification here. And other examples, of course, your social security card, your driver's license, etc. But anything that pins you down directly and unambiguously is tier 1. And of course, as you move up and down the tiers, the risk decreases and the pressure to protect it also goes down a little bit. But more holistically, you want to protect your data as if it's all tier 1, because if you protect your data badly just because it's tier 4, you've created weakness and bad habits, and at some point all of that creeps over to tier 1 as well. So this is an exercise to measure risk, but don't use it to undermine your protection and security mechanisms. And then, of course, the second step is, now that you've classified your data, you want to come up with an internal theoretical understanding on how you would protect that data. So depending upon the tiers, you now have an understanding of this is tier 1, so we need to throw everything at it. Tier 2, maybe we can be a little more relaxed. At least come up with an internal understanding of how you would do it. And when it comes to collection, when it comes to access, retention, deletion, etc. But just to go back to the left-hand side of that slide, as I mentioned before, data classification answers two fundamental questions, like what is this data and what would happen if it were to be compromised. The handling requirements answer a third equally important question, which is how would you protect the data now that you know how risky it is? So these two steps are in sequence for a reason. The third step, which is something we will be looking at into great detail, is the data inventory. This is especially important because it's at this step that you tag the data based on the classification that you arrived at in stage 1, so that you can protect it based on the standards you have set in stage 2. Unless you do this step, everything you have done is only planning, and any planning without execution is just words on paper. So something to keep in mind. So this is sort of a very, very basic diagram. I'll go into a more savvy diagram in the next slide. But think of this as a funnel that demonstrates how data enters your company. The far left is where a customer first comes into contact with your services. And as data enters your company, it grows. You infer stuff from it, it gets copied, it gets shared, you have data coming in from other sources. The size of data grows. Sometimes the data will grow faster than the size of your user base. So if you want to classify and inventory your data, which you should, in my opinion, as early as possible, do it on the far left of that funnel. Because if you do it later, it gets more and more expensive. This makes the point even more. This is something I showed our leadership when we pitched for a budget, and it didn't really lead to much of a conversation. We got everything we wanted, because unless you do data inventory before data is used, everything you have planned for falls flat on its face. And you will notice after collection, we have inventory right off the bat before use happens. And I'll show diagrams later on in the presentation as to how this works. So why is data inventory hard? Even if you do everything right, like I just described, inventory is hard because typically you do it when there's been a breach or a consent decree or a law changes, or you realize, oh my goodness, this is not really working because you have too many customers asking for copies of their data. So you typically do it late in your growth process as a company. In fact, I was talking to a few startup entrepreneurs last week. None of them had privacy hires in their first or second tranche. So typically people like me come in when enough growth has already taken place. So it's going to be hard no matter when you do it, so better do it sooner rather than later. So when it comes to data inventory at Uber, we thought of it as 5 logical infrastructural steps. The first is we needed something that could crawl all of our data stores and then discover our data sets, make those data sets and the corresponding metadata available, and then enable the addition of new metadata, because engineers always showed up at the last minute saying, hey, you didn't catch my data, I need to make sure it's tagged as well. And then there's a 5th step, which is actually applying all the tags from a privacy perspective. Now, I would argue that steps 1 through 4 you would need to do anyways, from the sake of better data hygiene and data science, just to make sure that people can actually use their data for marketing purposes. So I would argue that steps 1 through 4 should not be thought of as a privacy expense. In fact, for those of you who run privacy and security programs, talk to your data science team and figure out a way to split the cost so you don't have to argue for a privacy program from scratch. Your life will be much easier. You can thank me later on for it. So our system that does data inventory is called UMS. It's the Unified Metadata Management Service. So I'll be referring to it as UMS in the interest of time, since my deck is kind of long. And this is the diagram that really sort of explains everything that I just talked about. So UMS is basically the be-all and end-all. It will crawl the data sets, discover all of them, pull those in as required, as I mentioned before. But the 4 key numbers here are what I really want to talk about. On the left-hand side, on the top left, is the legal data classification step that I mentioned. That was the one where you partner with legal to come up with that conceptual classification. Number 2 is where you convert that classification into machine readable tags so you can apply it to the data. Number 3 is where you apply policies. Those are handling policies you talked about. And then number 4 is where data is gushing into your company. And as you notice, UMS is where all the tags and the attendant policies live. And number 4 is where all the data gets pushed in. So UMS is where all the magic happens, where all the data meets all the logic in terms of protecting it. So that's, again, something to think about in terms of how you would protect it and how to make sure that data doesn't flow to the users before it is classified. I do want to call out the backend a little bit more. So this is, again, a finer, honed-in version of the diagram here. So on the top left-hand side, you have the ability to refresh the data catalog. So the data doesn't get pulled into UMS automatically. We had to build a lot of infrastructure to make sure that there were multiple pipelines for the data to get into the UMS. So we had crawlers, we had a UI portal that engineers could use, but there were multiple ways to make sure that data was available for the purposes of tagging. And then you have the 2 boxes in the middle under the classifiers column, if you can think about it. We have the ability to manually categorize the data. So a lot of engineers knew exactly what they had was tier 1 or tier 2 or tier 3, and we give you the chance to label your own data. But we also have 3 algorithms in the middle that are very, very AI driven that will do categorization based on crawling and sniffing of column names or JSON expressions, etc. So we have several ways to make sure that data inventory can happen and under the classifier section. But then we don't just take your word for it. Like if an engineer decides that an SSN is tier 4, it's public, let's not protect it, that's obviously not going to fly. So we have a decider algorithm on the far right-hand side at the very top that will check one more time to make sure that the data is correctly tagged and classified. So this is the diagram again from a different point of view. As you notice, I'm calling out UMS twice. The UMS on the far top left-hand side, the second box on the left under data stores, it basically feeds the classifiers and enables that all the classifiers get information like the column name, the column type, any manual categorization that has already happened, etc. And the classifiers will use this information to do the appropriate tagging of the data. So UMS is both the initial recipient of the data and also provides the right metadata information to make sure that the classification can happen correctly. And then on the right-hand side, the column in the middle, UMS is the data store post-classification. So once the decider is done, all the data gets spit into the decider. So you think of it this way. You have all of the infrastructure set up, you have everything that is scattered, but UMS is the only place where we want data classification and the tagging and the housing of data to happen. If you are looking at data in the UMS, it is either data pre-classification or data post-classification. It is the only place where this happens. It's again aimed to make life easier for the engineers so they don't have to go hunting for data that is appropriately privacy secure. So I was talking to a buddy of mine at Facebook in terms of why privacy engineering is hard. And the innovation here is that engineers are going to do whatever is easy. And you have to make it very easy for them, because if you make doing the wrong thing easy for them, they'll do the wrong thing. If you make the right thing easy for them, they'll do the right thing. So UMS is privacy central. And our CEO, Dara, likes to say that we grew in a very, very decentralized fashion. And as a result, the company grew very quickly. But in order for us to make sure that privacy is done correctly, there has to be a level of centralization. And I know the words process and bureaucracy and centralization often rub people the wrong way. It was that way at Netflix and same way at Uber as well. But you have to build all this automation to make sure that privacy is centralized, and UMS is our way to do that. So data inventory needs 2 key attributes, basically. And this is, again, getting into the infrastructure. We need a way to capture the metadata as much as possible, so right across our infrastructure. And we need a consistent metadata definition. So metadata management at Uber spans not just the data sets, but also all the entities. So the UMS, as you can see here, it captures metadata about the online, offline, real-time data sets, as well as ML features, dashboards, business metrics, etc. It collects a lineage, basically anything that has anything to do with the underlying data that will instruct how that data ought to be classified. UMS has the ability to pull into the pipeline. And because our metadata service needs to manage data across different sources, so we're talking about Eats data, freights, ride, etc., someday ATG as well, which is the self-driving car, we've built this infrastructure to make sure that metadata gets classified the same way, regardless of what the data source is or where the data comes from, so that when it comes to being classified, it is platform and business line agnostic. Tier 1 is Tier 1. So if you have a driver's license for a freight driver versus an Uber Eats driver, it's going to be classified as Tier 1 regardless. So we use a taxonomy-like structure. So in this example, and it's pretty intuitive for anybody who looks at this demonstration, the MySQL table and the relational database are defined as entity types because they are the abstraction of a physical entity. And you can see that the MySQL table is defined as a relational database, and the value of its name is UUID. So again, it's very, very intuitive, it's very easy, but initially getting this definition right required a lot of participation from people who define the database schemas, people who had no understanding of privacy at all. So you literally had people who knew privacy but didn't know our infrastructure, and you had people who knew the infrastructure but didn't know privacy. So the key for us was at what point does the Venn diagram intersect enough where we could understand their world and they could understand ours? That's when we could build privacy right, and they could make infrastructural decisions that would make privacy easier to implement in the company. So this is a process we went through over several months. So once the metadata is well defined, that's when we came to the point. So this is where we are coming into full circle. So that's when we knew how much data we had across the company and where the data was and what pipelines needed to exist for what infrastructure. So we built the crawlers to make sure that we could essentially tailor the push, and we didn't overwhelm the receiver. So there was some throttling available, and we used UI listeners, we had APIs, we had the UI that people could enter data manually. So there were a ton of investments made by different teams who pitched in, who realized that they couldn't do this manually. So this brings me to our AI categorization. So this is the AI model in the middle. Remember I showed you the two squares in the middle, that one of them was the manual, the other one was the AI driven. So we had to make some trade-offs when it came to actual categorization algorithms. So when it came to the coverage, accuracy, and performance trifecta, we couldn't get all three. So we literally had to apply different algorithms upon different pipelines, depending upon what our use case was. So you'll need to play around to see exactly how it optimizes, because at the end of the day, you do not want to slow down the data to people who are making real-time decisions around who gets to get what recommendation when they look for Uber Eats, for example. So again, this is a bit of a rubric for how we pitch in terms of our risk when we present to the executive suite about how much data we have and what percentage of it presents a risk. It is extremely critical that you have a message that is very crisp for privacy, because I have engineers who work on our teams who get down to the most granular level of detail about how the crawlers work and how this algorithm works, and it goes over the head of our executive suite, and it almost looks like we're bragging about our technical skills rather than making a case for privacy. So you really want to condense your message to something that looks like this. So when you have to make a pitch for investment, when you have to make a pitch for prioritization, you are making it based on numbers that are aggregated based on all the learnings and all the infrastructure you have built up. I have done it the wrong way, I've done it this way, and this way works better every single time. So this brings me to sort of the end of the first half of my talk, which is privacy challenge number one, which is security, as I mentioned before, is the foundation upon which privacy is built. But at what point are you collecting so much data that your security infrastructure cannot keep up? So there's 4 key learnings, and you have to sort of look for all of these learnings as you grow your program. So at what point do you have so much data that protecting it becomes prohibitively expensive? That's the first slide. I kind of jumped the gun a little bit. So that's again something you need to think about. At what point can you not delete your way out of trouble? The second thing is, at what point do you hit the inflection point where you stop discovering data that some engineer has tucked away in some S3 bucket because, hey, I might need it later on. So when you stop getting those surprises on a regular basis, that's when you know you've turned a corner a little bit. The third is, what do you do when your ability to delete your data at scale is dwarfed by your data collection? So what do you optimize for? Do you keep increasing your deletion infrastructure? Like, do you throw more money at it? Do you put more people on the team? Do you stop copying data? So again, these are things you need to watch for. The fourth thing you want to look at is, what does privacy do to help data quality? So if you have so much data that you cannot delete it, that you have to keep adding infrastructure to it, at what point is your data becoming useless? Now, when we were helping one such team at Uber, we found out that a ton of their data was basically the capture of information when people minimize the Uber app while waiting for their Uber driver. So this must have been a busy day, so people were minimizing their app again and again, and that got captured. 70% of the data was just that blank data. It was totally junk data, but we were running queries against it, logging against those queries, so we were storing copies of junk data. So not only is that garbage data, it was not a privacy risk, but it was just useless data. So when you run the privacy program well and you ask those questions, you could actually end up helping your data science team. You could help save on storage costs. So again, don't let the privacy program get this reputation of being a cost center or a slow down machine. You could pitch this as a way to help your business. Remember this. So this brings me to the beginning of the part 2 of my conversation. We've talked a lot about data collection and how you protect data on it. Let's talk about data sharing. And before we get into details, another story. The first one is about me and my spouse. This one is just about me. So about 5 years ago, I used to weigh 100 pounds more than I do right now. I was really big back then. And I lost that weight by running in the morning and using an app called Strava. And I still run every morning. I get up at 4 and run about 10 to 12 miles every day, depending on what I feel like it. And it's a great app because when you run with Strava, it lets you log your run, it lets you log your starting point, your end point, and it puts a little heat map that gives you a sense of community about who else around you is running and where they're running around you. And this feature was insanely helpful because it let me get back to good health. But turns out it also gave some headaches to Strava, the company, and the US military. Turns out 5 years ago, I was not the only one that was running. Our troops and on military bases across the world were running as well. And a lot of you might know about this example since it made some news when it happened. Strava is a great company and they've made a ton of progress and we've all made mistakes. So this is not schadenfreude by any stretch. There's enough bad stories about all of our employers, so let's not smile at them too much. But this is a learning experience. What happened in this instance was you had enough service members in enough of these bases running and logging their runs. And even at the early stage in Twitter's life, there were enough people who were able to look at those models, connect them to external data, and identify these military bases. Now, this is not by itself a problem because most of those bases are public, but these runs identified not just the bases, but also supply routes to the bases, mess facilities, training facilities, other ways in which people were coming back and forth between those bases. In fact, with the help of other aggregated information, you could identify which service member was in which base. In fact, researchers also found out after the fact that if you blurred out the starting point of the run and the ending point of the run, you could still identify all the soldiers, all the bases, all the supply routes, everything. So basically, because some people decided to go for a run using Strava, you had a whole bunch of US security military infrastructure just outed, just like that. Now, you might wonder what Strava was thinking, and they genuinely didn't foresee this coming. And when this news hit, their response was that you can change your settings to make sure that this is not broadcast on the heat map. And that's true as far as it goes, but for those of us who work in privacy and security know that if you have to explain how your tool works after a privacy or security issue, you've kind of lost the argument. That's just how life works, and I've been there myself, so that's just how it is. So you own the security and privacy of your data the moment it enters your company, and you especially own it the moment it leaves your company, because if a third party or a vendor mishandles it, they didn't do it, you did, because you gave them the data. So that's just how, again, the story plays out. So before you make decisions in the name of growth, in the name of adding a ton of users or making a ton of money, remember to not trade today's headache for tomorrow's migraine. So in order to prevent stuff like this from happening, what we have at Uber is sort of a two-tiered program. We have the legal team that runs a privacy impact assessment. That is something that GDPR, CCPA, any number of standards and regulations require. But on top of that, I started a program called the Technical Privacy Consulting, which does two things. It helps the attorneys during the impact assessment, so they have somebody who's an engineer who can help look at the ERDs and the PRDs and the design documents to understand what might happen if other people who are less privacy aware make bad decisions. So that's number one. But we also work with engineers more informally. So if you are an engineer who finds data someplace and doesn't know what to do with it, we will help you. If you don't know how something might actually play out, if you need to understand what privacy techniques are available, we will informally whiteboard the solution for you well before you even write an ERD or a PRD. So that informal engineer-to-engineer contact without any process, without any judgment has been very, very helpful. And it's impossible to prove a counterfactual. Like, I can't stand here and tell you, here are all the bad things we prevented, but there is a lot of satisfaction in catching something before it becomes worse. And I would recommend this model because it's, again, when we do this model, it helps us improve our internal privacy tools because we know the sorts of things people are willing to do with data. So initially what we do is we ask very, very high-level questions just to ease the team in, like how are you protecting the data at rest in transit? What is the level of granularity that you're collecting or sharing it in? How identifiable would the user be? Is there any aggregation or anonymization being applied? And if there is a third party involved, are they monetizing the data? What does that transparency look like in terms of what they will do with the data? And then when it comes to data sharing, so we've talked a lot about sharing, but again, coming back to Uber, there are valid reasons why you might want to share data, even things that go beyond the normal stories of growth. So a lot of municipalities, now Uber needs to work with city governments to get licenses to operate the cars and vehicles on the street, bikes, etc. So cities need to know the impact on traffic, on parking, on emissions, etc. They also need to collect per vehicle fees. They need to enforce parking rules for bikers, bikes, scooters, etc. Although the way people drive in the city, I'm not sure how well that's working out. They also need to respond to service and maybe health outages. So you need data about these cars and bikes and scooters. So again, there is a valid use case. You also need drop-off geolocations at time to get the real-time impact on traffic during rush hour, for example. You might need trip telemetry information to find out and make sure that you are not going in no-go zones like hospitals, for example, where you aren't allowed. You also need driver's license numbers or vehicle plate numbers to make sure that you aren't driving with expired plates or you don't have an Amber Alert, etc. So there are real-time values to society to this data sharing. Now, when it comes to data sharing, I cannot get off the stage without talking about something that's very, very contemporaneous. For those of you who, anybody read about this story in the news with Uber and the city of LA? Okay, so a couple of heads nodded. So there is an argument going on. I obviously won't go into the legal aspect of it, but I'll talk about at a high level about the dispute that is going on between Uber and the city of LA. There are demands made by the city of LA about trip data that I believe and the team at Uber believes are extremely invasive and not privacy-centric. So let's talk about what those are. The city of LA wants real-time trip tracking on their API. Now, I have a couple of problems with it. One is, as I mentioned before, there is no real reason to have real-time data. Like if you want GPS pings every few seconds, you don't need that for every single vehicle unless there is a real health issue. So you could be a little more selective, but the city of LA sees it differently. They want precise trip start and stop coordinates. Remember the Strava example I just mentioned a couple of minutes ago? You had troops on some of the most secure bases on the world, and they were outed even after their start and endpoints were blurred. The city of LA wants real-time locations. Now, what if a city with a more specious human rights record needed that information? Would we give that information away? So again, another use case to ponder over. They also need parked vehicle GPS locations. And the city of LA does not have, unlike a lot of other cities in the US, they do not have privacy guidelines that are published, any anonymization techniques that we can evaluate, and they have not committed to non-monetization. That is, they could use that data for money purposes. And then of course, they might extend that to privately owned vehicles. So if you decide to drive for Uber or Lyft tomorrow, your data might end up with the city of LA whether you want it or not. So that's kind of what the dispute is about. So I'm trying to distinguish between, at least from my perspective, what I see as a valid use case and one where I do not see it as a valid use case. So we're defining several guidelines. I'm going to speed through a few of them in terms of how we try to anonymize the data before it leaves our company. So we ask vendors and partners to document retention and deletion policies so we can evaluate them. But even beyond that, if you look through from top to bottom, when we share with you unique identifiers and precise times at whatever level, you can only keep them for a very small period of time. Again, the 90 days is an example. That's not the precise number. It varies on a case-by-case basis. But then if we coarsen the data, that is, make it more approximate, you can keep it for longer. So, and again, if you go down further, we look for even higher degrees of data approximations. The big takeaway from this slide is that if you have data that is very precise and very specific, you keep it for less time. If you want to keep data for longer, you make it coarsening. So you got to pick between longevity and accuracy. You cannot have both because privacy always loses out when you have both. We also ask that you remove any unique identifiers. So if we give you IDs that uniquely identify you as an Uber driver, when you get the data as a city, for example, take out that ID and put your own. So heaven forbid if the city of San Francisco gets breached tomorrow, the person who breaches them should not be able to identify me as an Uber driver or Huang as a Lyft driver. We should be indistinguishable, basically. And then we also want to dispose of any personally identifiable information or replace with values that are generated with a pseudo-random function like HMAC SHA-256. But again, this is where you want a security person at the table because these techniques may vary on a case-by-case basis as well. And then we also want you to coarsen the precision of any stored data. So for example, round times to the nearest 30-minute increment. So if you leave at 12:22 and I leave at 12:30, it gets stored in the database as two people who left at 12:30. That, again, it's a little more approximate. Again, it's only 50% more privacy, but again, across a vast sample set, you get a lot more anonymity that way. And then you convert the GPS coordinates to the nearest start or end or the middle of the street or round it off to a certain number of decimal points. For example, in this case, 3 decimal points. Now, let's assume that you're sending a file off to somebody else and you think you've done all this, like I've gone through 4 slides. That's a lot of coarsening. You've really beaten the crap out of this data. You got to assume that there's got to be some privacy here, right? And we were doing a study on this recently at Uber, and we saw this tweet, where if you look at 3 decimal points and stacked over 15-minute increments, that square is what that looks like. And if you have a really big campus, like a hospital, or a university campus like Stanford down the street in Palo Alto, I can easily identify that you went to Stanford and you went to one of 3 buildings. And if it's not a busy time on campus, like if it's spring break, or if it's like the Sunday right before spring break ends, or whatever, it is pretty easy to identify you because the number of rides will be very, very limited. So even if we do everything that we have done so far, it is extremely difficult to guarantee privacy, or at least you cannot just send the file out and assume that privacy is all taken care of. So we are leaning heavily into k-anonymization at Uber because it is literally the only way where before data leaves us as a company, we can come very close to guaranteeing that you have some degree of privacy. So what is k-anonymization? So what we do is we make sure that for whatever degree of k-anonymity, there have to be at least X number of other people that share all your vital attributes. So if you talk about K2 anonymity, there has to be at least one more person. That goes back to the example of the 12:30 ride where you left at 12:21 and I left at 12:23. If you round it off to 12:30, we have a K2 anonymity. Again, that's kind of an oversimplified example, but you get the general argument. So we practice k-anonymity using our Uber movement portal. So this is a pretty nifty tool. I use it every morning because of my commute. It basically gives you the approximate time to get from location A to location B, and this basically takes you from Santa Monica to Inglewood. And in this example, this tool is useless because there were not enough rides. So if we give you the average time, we're essentially giving you the times as close to possible as maybe the 3 or 4 people that took those rides at that time. So there has to be a certain number of people who took the rides for that data to be privacy centric. Also, if only 2 people took the ride, that data is not very useful anyways, because the average with very small numbers is pretty useless. So another example where doing the right thing for privacy improves data quality anyway. So make that argument when you pitch privacy the next time. So in order to really give this presentation, I had somebody on my team do a case study for 40,000 Boston trips, and some interesting learnings about k-anonymity came up. Now again, I'll caveat by saying that these might not be representative of anything you try because this was a specific cohort of 40,000 rides in one city in the US during a certain time frame. So pick 40,000 different rides and a different learning comes up. But here's what we found out. So look at the top row here. If I give you 0 decimal points on the GPS, by the way, before I jump in, when you go from 0 through 5, that's the number of decimal points we give you for the GPS. And if you go from 2 through 1,000, that's the k-anonymity. So if I give you 0 decimal points, that's pretty coarse data. That's very, very approximate GPS location. And at that point, I can, at least for those 40,000 trips, find at least one other person, all the way to the right, at least find 999 more people. So all the way from k-anonymity of 2 through a k-anonymity of 1,000, I have 100% coverage. So it's extremely privacy centric. The problem is somebody in business or somebody on the data sharing side might say something saying that this data is not very helpful. So you have to find a way to make sure that your data is not totally useless. And at what point do you feel comfortable that there is enough privacy and make the data a little more useful? So let's look at the other end of the spectrum. So you have 4 decimal points and 5 decimal points. So let's look at 5 first. If you look at 5 decimal points, you're basically giving a very, very precise GPS location. So if you want a k-anonymity of 2, you have 68.4%. That is, for 68.4% of the users, you could find one other person with the same ride. So your anonymity rate went down from 100% in the previous slide to 68%. You literally lost a third because of the 5 decimal points. But then let's say you shave off 1 decimal point. That is, you go from 5 to 4. Your anonymity goes for 2 from 68.4% to 97.4%. So basically, at that point, 97.4% of people have somebody else who meets their anonymity as well. So that 5th decimal point destroys a lot of privacy, but gives you very precise data. But then the real problem is on the far right. If you want anonymity of 1,000 and you are a very, very risk-averse company, if you have 5 decimal points, not even 1% of your people can be anonymized. And then if you shave off 1 decimal point, you get from roughly 1% to 17.3%. That's roughly a 1/6 of your population. So if you have a very, very risk-averse legal department and you want to give 5 decimal points, that's not going to be a fun conversation, as this diagram tells you. Again, with a different cohort, your findings might be different. I keep caveating that. But the industry best standard from everyone I've talked to, people smarter than me, is 5. So if you look at k-anonymity of 5, that is, you want to make sure that there's at least 4 more people with that level of anonymity as you. If you have 5 decimal points, you have 35.5%, which is not great, but not terrible either. But then when you shave off that 5th decimal point, you have 93.2%, unless my site's a little bad. Yeah, it's 93.2%. But then if you shave off 1 more decimal point, that is, you have 3 decimal points, you have 99.8%. So only for 0, you can shave off 0.2% of the data that is identifiable, and you can give 3 decimal points, and you have an anonymity of k equal to 5. So this is where you can have the legal team feel secure that you are not compromising privacy. You can have some level of precision of your data. So this basically means that you might need to do this on a case-by-case basis. Everything else we've talked about so far is sort of a top-level sledgehammer. It will work across all your data. But when it comes to sharing a specific file, you might need to do some detailed investigation to avoid any kind of privacy mishap later on. And this was a fun exercise because we tried several different cohorts. This one was one where the numbers were very stark, so I brought it here just to make the example sink in. We have other examples as well in terms of what we ask municipalities to do. We want them to give us their error tolerances and some detail about what they'll use the data for, so we can use it on our side to manipulate the data so that they can use it, but we don't have to worry about the privacy, but we don't end up destroying their experiments either. So let's also look at how other places do some of this data sharing anonymity. So the point behind this is that there are cities in the world, in the US especially, who do some of the same things we do. We're not just uber privacy crazy people. There are cities that replicate some of our best practices. The city of Minneapolis, they basically get trip IDs, but even if they're hashed, they discard them. They create new IDs in lieu of Uber or Lyft IDs. And they also drop start and end points. And they also round off the start and end pickup times as well. So everything I've talked about, if you get pushback from within your company, you can point to the fact that other cities and other responsible third parties also follow some of the same practices. And they also restrict their data significantly in terms of APIs and table access. They do not store any data in real time that is being used for processing. That is only stored in memory. But the processed data, that gets stored to disk, but at that point it is extremely aggregated and anonymized. And they also round off the pickup and drop off start points. So if you notice at the very top, that was a starting point. And then they split the three into quadrants, into three quadrants for the street. And they round off the pickup or the drop off closest to where the point was relative to the middle three. So the cities have maps and they use them very well to anonymize them, at least the city of Minneapolis does. So as I get to the end of my talk, we also did a recent lunch and learn on privacy and precision. So the research paper is linked here. And the point behind the study was, could your digital fingerprint identify you more than your real fingerprint? So the research paper talked about how 12 points can uniquely identify your fingerprint. So you need a certain number of points, and the more points you need, the more privacy-centric that metric is. So 12 points for a fingerprint. They also looked at 1.5 million people over 15 months, and they looked at how do you identify those people based on their mobility traces. That is, if you look at who they are and where they are, for 95% of the people, in terms of a sample size of 1.5 million over 15 months, 4 spatial temporal points would identify them, 95%. So this makes it extremely hard when it comes to giving privacy, especially if we know who you are and where you are. And they also found out that as they made data coarser, for every 10% of precision that they lost, they only got 1% of privacy. So at some point, it becomes a trade-off between how much privacy have you lost and how much privacy have you gained versus how much data is still useful. So that's something else you'll have to look at, and there's a slide coming up soon here. And this graph really makes the point pretty well. If you notice, I'm going to get a little closer. On the bottom left, you will notice, and this is unfortunately licensed in the paper, so I didn't have a better resolution. But at the bottom left, you see 80%. So when you are still on the graph, at the very, very close levels of spatial resolution, which is on the vertical axis, and temporal resolution, which is on the horizontal axis, 80% of the people are identifiable. And then you lose 40% of resolution on both sides, and you still have 70% of the people identifiable. So you've basically lost 30% of precision, and you've only gained 10% of privacy. And then you pull out even further at 60%. At that point, you're almost off the charts. And then when you get from 50%, you're pretty much off the charts. And it's only when you get to 40%, you'll notice that the top line is to the right of the A, and the bottom line is already on right above 15. So the question is, inherently, there is a tension between the quality of the data and the amount of privacy you can get. So, which is why I mentioned before, k-anonymity is so helpful, because the idea that you can build out an infrastructure that will bail you out every single time without you looking at it is simply not real. You're going to have to make that investment, and that's why you need a centralized privacy team to at least provide that data to your company. So, and this is of course the challenge of outside information. That is, there is information available outside the company that can help identify someone, and the people who wrote the paper found out that if they looked at medical information and a voters list, they could identify the sitting governor of Massachusetts. Like, they were able to identify this person, call the hospital, and get their medical record. That is how much information they were able to get. So how do we solve this? And this is, I promise, the last 2 slides of my talk. Thank you for the warning there. We are looking at a brand new technique called data minimization. And I know it almost sounds cliched, but we're working with teams across the company to figure out a way to just start collecting less data. And I'll hopefully be the topic of my next QCon talk. We're looking at folks who write services to basically let people call Uber rides or order Uber Eats. And how do we make sure that we don't collect things like the location, for example, in the header, and we use it from the platform where we already have that location. Because if it's in the header, it enters the system, it gets stored in other systems, get copied everywhere because it's incoming data and it gets copied fresh. So how do you make sure that you collect data as little as possible and make sure that people don't have access to the data to begin with unless they absolutely really need it, in which case they know exactly where to go. So data minimization is a heavy point of investment for Uber, because when you have less data, there is less data to classify, less data to tag, less data to classify and rank in terms of those ML classifications, less data to anonymize, and less data to worry about being joined with external third-party data. So this is something we're leaning in pretty heavily on at Uber, and this is going to be my focus, my OKR for the next year. So these are the 4 key takeaways for the talk here. Privacy is not just for attorneys. I've said this many, many times. It's a cross-functional discipline. Know what data you have, why you need it, tag it, inventory it early in the process as much as possible. In using and sharing data, make it as coarse as possible. Apply a whole bunch of techniques. There is no one technique that will get you out of jail. And finally, as I mentioned before, minimize your data. With that being said, we have a whole 3 minutes for questions. Thank you. Thank you.
Two quick questions.
Sure.
On the UMS system, how do you handle PCI compliance and HIPAA if you're funneling all that data through that system? And then the second question is, I happen to be from the Minneapolis area. How did you select Minneapolis, and is it really just Minneapolis that is doing that across the United States or requiring that?
So I'll answer the Minneapolis question first. So Minneapolis is an example. They have not only done all of this stuff, but they've published a lot of this as well. So, and the reason Minneapolis was instructive is because in a lot of our conversations with other municipalities, we point to Minneapolis because it's often easier for municipalities to get this information from each other rather than from a company, because from a cost perspective. So, and also the APIs that Minneapolis uses are also universally used by different municipalities across the country. So the city of Oakland also does an amazing job as well. They have a well-published one. A lot of their stuff is much deeper. My talk would have been twice as long. In fact, theirs is even better in my opinion, although other people at Uber disagree, but they're both extremely good. Up to your first question, when it comes to HIPAA, that just gets run separately. HIPAA and PCI, HIPAA and especially some of that tokenized information, because of how financially or health sensitive it is, that is just run totally separately, because a lot of that information came in first. In fact, from my Nike days, when I found out that height and weight was being looked at as personal health data by the Dutch TPA, that lesson was learned pretty early. This was built primarily because there was a ton of other data that also became thought of as more and more protected data. So we needed something that could just manually allow people to categorize it at scale. And with ML, you don't need all that with PCI and HIPAA. It's like, you know, it's sensitive. So it's almost like, let's not make an easy problem hard, let's just pay the cost. So we almost have that 2-tiered structure. So a little caveat to my talk, but thank you, good catch there.
Great. Well, we have one more question here.
Sure.
So I was wondering if you could speak to the political challenges of, because all of this, getting people to classify data, getting developers to use tools and things like that, it requires work for them to do. And I was wondering if you could speak to some of the political ways to handle that.
Yeah, there's a saying that either you will pay for privacy or you will pay for not having privacy, and that cost is much higher the second time around. So I've always been lucky. I've always entered companies after something bad has happened. So I got into Netflix after the consent decree with the Netflix challenge. I got into Nike just as the Dutch DPA stuff was happening. I got into Uber after the challenges the company had the last 2 years. So sometimes the past makes it easier for you to be in the present. That's part of it. Also, the company had just gone through tremendous challenges because of GDPR. It was an extremely prohibitively expensive endeavor. It cost a lot of money. It also delayed a lot of things on the roadmap. So when you can present the before and after of what it would look like if you were to do this right now, it helps. Plus, I've been a product manager before. I've been the data collector before. So I can tell people what it was like to clean this up because I didn't do it right the first time. You really want to have people in your team that have the infrastructure, the product experience. Don't just fill your privacy team with policy folks, because otherwise the engineers will talk over them and then you really won't have that synergy. You want people who have the empathy, who understand what it is like to build these tools and at what point these tools are actually useful. So it's not easy, but that's kind of how we've done it. So. Sure, thank you.
Thanks for the session.
Sure, thank you.
So I have two questions actually. One is, say there is a huge amount of data coming to the organization in order of GBs of data per minute or per second maybe. Am I audible, right?
Yeah.
Yeah, so that is huge amount of data coming to the organization via ingestion. So how do you make it, minimize it in an efficient way such that the next flow does not get impacted? And my next question is, okay, first of all.
Sure, I can take the first one. So I don't have a whole lot to share right now because we're still kind of in the ideation phase. But let me give you an example. When I would talk to the location team, for example, if they send the location in the header, that header gets propagated literally across the company. So people who don't need the data, who don't know that they have the data, start collecting it. They start storing it. Their jobs run against it. They log it, right? So sometimes it's about the real privacy challenge starts when people mishandle data that they didn't know they had. Because if they don't know it, they don't categorize it, they don't do anything right with it, right? So how do you challenge people to understand what do you really need? So this is why I talked about with the gentleman's question over there. You want to make sure you have people who have the architecture and the product background, because they can ask questions like, okay, let me help you architect this product. I advocate for privacy, but my job is to help you build your product better. And when you do that with the 3 or 4 key marquee services in the company, that information starts percolating down. And then you might break some things when that data stops coming and you find out who really needs it. So there's going to be a little bit of hit and miss, but you need to come at it from the architectural perspective early at the edge layer. So there is another question as well?
Yeah, so say there are multiple data providers, third-party data providers, which are sending the data to my company. And if they are sending the user data, then is it my responsibility to hash the data or to minimize it?
So my argument always is going to be the first person who touches the data hashes it, but I think your question goes to the legal policy side of it as well, and I'd hate to be an attorney. I'll always argue for let's hash it or let's anonymize it as early in the game as possible, but I would consult with your legal team just to make sure. Okay. Awesome. Great.
Great. Well, thank you so much. Thank you again, Nishant, for the great presentation.
Thank
Super
you.
interesting.